So now let us try to understand what are the complications that come in finding the limits. So till now, whatever are the functions that we have taken, those are very easy functions. That is, if I have to find a limit x tends to a f of x. So how do I do it? So let us take an example. So limit x tends to a, x tends to 2, for example, x square. So if you have this limit, so this limit is not very difficult to find. So whenever this function, whatever function you are given, if this function doesn't have any complications around this point. So in the chapter of functions, you have dealt with the graphs of basic functions. So if the given function does not have any complications, that means any jumps or discontinuities or undefinedness at the given point, so you can directly substitute this value in this function and get the answer. So that is, this method is called method of direct substitution. So if you want to find the limit, you can directly put this value of x in the function. And this can be done as long as the given function does not have any complications in terms of undefinedness or in terms of jump at the given point. That is, the graph near x is equal to a has to be something like that. So there should not be any undefinedness or jumps at this point. So as long as that happens, you can do the direct substitution. So there is no complication in finding the limits. So limit x tends to 1, x square plus 3x minus 1 by x plus 2. So this is a rational function which will have discontinuities or complications around x is equal to minus 2. But you are asked to find the limit at x is equal to 1. So at x is equal to 1, there is no problem with this function. So you can do the direct substitution. Put x is equal to 1. 1 plus 3 minus 1 is 3 by 1 plus 2 is 3, which is equal to 1. So when will the direct substitution do not work? When will this direct substitution not work? So for example, if you have limit x tends to 1, x square minus 1 by x minus 1. So if you're asked to find this limit. So I might say that I'll directly put x is equal to 1 in the numerator and denominator. So as you can see, you're getting on direct substitution, so you're getting 0 by 0. So what does that mean? It means that f of 0 is not defined. That is, you have some problem of definition at exactly x is equal to 1. So in this case, direct substitution do not work, obviously, because on direct substitution you got 0 by 0, which is called an indeterminate form. Indeterminate form, that means you don't know what the value is. So this here, direct substitution do not work. But you cannot say that limit does not exist, because when you are talking about limit, you're talking about what happens to this function at the neighborhood of 1. I don't really need what is happening at exactly 1. So at exactly 1, you're getting 0 by 0. That means at exactly 1, the function is not defined. But as x is getting closer and closer to 1, if x is not equal to 1, if it is getting closer and closer to 1, where does this limit go? So whenever you get an indeterminate form on direct substitution, you need to do further analysis of the function to find what is happening in the neighborhood. So for example, if you have this limit x tends to 1, So I take x square minus 1, I can see that it is x plus 1 times x minus 1 divided by x minus 1. So I am just applying some certain process. So as x is tending to 1, that is x is not equal to 1, x is closer and closer to 1, but it's not equal to 1. So x minus 1 is not equal to 0. It is tending to 0 but not equal to 0. So as long as the number is not equal to 0, I can cancel these two. So this is exactly same as limit x tends to 1, x plus 1. Now this function is good. Now you can do the direct substitution, which is 1 plus 1 is equal to 2. So the complication in finding the limits occur when you get indeterminate forms on direct substitution. So 0 by 0 is one of the indeterminate form which occurs. There are other indeterminate forms also which might occur on direct substitution. So now let us look at the different indeterminate forms that might occur on direct substitution. There are 7 indeterminate forms we usually come across in our calculation of limits. Those indeterminate forms are listed here. So the first is 0 by 0, infinity by infinity, 0 into infinity, infinity power 0, 1 power infinity, 0 power 0, infinity minus infinity. So these are the 7 indeterminate forms which you come across. So whenever you get indeterminate forms on direct substitution, that means that the function is not defined at the particular value of x. It does not mean that limit does not exist. It only means that the functional value do not exist. So that's what you need to understand very clearly. So even when you get indeterminate forms, you can find the value of limit. For example, limit x tends to infinity, x square minus 3x plus 4 by x square plus 2x minus 1. So as x tends to infinity, x square also goes to infinity. So a very big number whole square is also a very, very big number. So minus 3x plus 4. So you have infinity square minus 3 times infinity. Obviously 3 times infinity cannot cancel infinity square. It is still a very, very big number. So this numerator goes to infinity. Now x square plus 2x minus 1, infinity square plus 2 infinity minus 1. This also goes to infinity. It means on direct substitution, x is equal to infinity. On direct substitution, this goes to the form of infinity by infinity. So you might feel that limit does not exist, but you can find the values of these limits. So we call this infinity by infinity as an indeterminate form. It means as x tends to infinity, the numerator also goes to infinity and denominator also goes to a very big number. So now what happens when you do the division depends on the relative magnitudes of these infinities. It is the relative orders of these infinities. So if the numerator has some order of infinity, that is for example 10 power 10. So the denominator has an order of 10 power 20. So on division you'll get 1 by 10 power 10, you go very, very close to 0. So when you divide two very big numbers, so if the numerator is of the form 10 power 23 is a very big number, and the denominator is of the order 10 power 10 itself, as x tends to infinity, as x tends to a very large number, so the order of denominator is less. Both are very big numbers, but on cancellation you get a very big number, hence it might go to infinity. Or if the numerator is of smaller order, if the infinity in the numerator is of smaller order and the infinity in the denominator is of larger order, so this becomes 1 by 10 power 13, which goes very, very close to 0. And if the two infinities are of the same order, it is one is of the form 2 into 10 power 10, the other is of the form 3 times 10 power 10. So you can also get a very nice finite number as the answer. So it again depends on the order of infinities of the numerator and the denominator. Now, limit x tends to 0 plus x times log x. We know that as x tends to 0 plus log x tends to minus infinity, x goes to 0. So what happens when you multiply 0 and infinity? So the trick here is, as x tends to 0, this x tends to 0 and this log x tends to minus infinity. Neither is this exactly 0, neither is this exactly minus infinity. So if you have exactly 0 into exactly infinity, that cannot be determined, that is undefined. Undefined is different from indeterminate. Here, whatever x I am talking about is very, very close to 0, it's not 0. And log x is very, very close to infinity, but not infinity. So now, the fight happens between these two. So 0 is something, a very, very, very small number, and it tries to bring the product towards 0. And log x, which is minus infinity, tries to bring the product to infinity. So now there is a tug of war between these two. So whoever wins, that depends on the relative strengths of the 0 and infinity. 0 has absolute strength, infinity has absolute strength. But this is not exactly equal to 0, this is not exactly equal to infinity. This is close to 0, this is close to infinity. So at that point of time, so it again depends on how close each thing is. So that's what we'll try to analyze later. And limit x tends to 0, 1 plus x whole power 1 by x. So if you put x is equal to 0, x closer and closer to 0, this is of the form 1 power infinity. So the base tries to bring the answer to 1 and the exponent tries to bring the product to infinity. Again, as you need to understand, this 1 which I have written is not exactly equal to 1. If the base is exactly equal to 1, there is no discussion. This 1 power infinity will be equal to 1. But here, the problem is that this is not exactly equal to 1 and the exponent is tending to infinity. Again, now there is a tug of war between these two. So whoever wins depends on the relative strengths of, relative closenesses of each of the term with the respective numbers. So limit x tends to 0, ln x power x. This is of the form infinity, log tends to 0, tends to minus infinity, power 0. This is of the form infinity power 0. This is also an indeterminate form. This is also a indeterminate form. So you need to look at the relative strengths of the base and exponent. So same thing with limit x tends to 0, x power x. So the form 0 power 0. The exponent 0 tries to take the answer towards 1 and the base 0 tries to bring the answer to 0. So when these two fight with each other, where does the limit go? That's what we need to find. And as x tends to infinity, x square by x minus 1. As you can see, x square is of the order of infinity square. The denominator is infinity minus 1 is of the order of infinity. So effectively x square by x minus 1 is of the order of infinity. Similarly, x cube, infinity cube by 2 infinity square. So this next term is also of the order infinity by 2. When you subtract one from the other, so where does this limit go? So these are several indeterminate forms that you come across in this chapter. And whenever you have indeterminate forms, you have certain methods by which you can analyze the limits. So what you need to understand here is, on direct substitution, if you find 1 power infinity, 1 that you see here is not exactly equal to 1. The infinity that you see here is not exactly equal to infinity, because obviously x is equal to infinity is not there. Infinity is not a number such that x will be equal to that. So infinity means a very, very large quantity. 1 means a number which is very, very close to 1. So what happens if you raise 1 power to another power? So you need to understand the difference between exactness and approximateness. So here on substitution, whatever indeterminate forms you get, so you need to understand that the 0 that you get in limit is not exactly equal to 0. The infinity that you get in the limit is not exactly infinity. 1 you get in the limit is not exactly equal to 1. They are very, very closely, they are very, very close to 1 or the numbers which we are discussing. So in this framework, let us try to understand different methods that we have to find the values of limits. So whenever there is no indeterminate form, you can directly do the substitution. The direct substitution is the first method. Whenever you are given a question on limits, the first thing that you do is you put the number directly in the function. If you get a nice number, that's the answer. But if you are getting indeterminate forms, you have to analyze them using the other methods.